Mr. Cartwright, you've just won Math YouTube Teacher of the Year. What do you have to say to all of your fans? So, while I was making this award for myself, I just wanted to realize there were so many people who came in and really gave it their all to make this thing possible. I'd like to thank my homeboy, Coach B. Rizzy, for the props. My main man, Jay Hat, for not firing Mr. Cartwright. Some student contributors, Dylan and all my friends who subscribed without actually being part of my math class. And most importantly, my math class, man. Couldn't do it without y'all. Much love. Stay tuned after the lesson video for the epic continuation of Mr. Cartwright Saves Halloween. Hey, how's it going, 9th grade? Good to see you guys. Welcome to day 22 of the online curriculum. And we are going to kind of pick up right where we left off the other day. So remember we talked about linear and exponential equations and how they have two similar parts of the same topic, right? So we need to find the rate of change, which is m in this case, or r in exponential cases, and wherever it crosses the y-axis, a or b. All right, so now let's try to find an equation for a line or an exponent from a table. So if we have a couple of numbers, right? Okay, so we have a table that looks like this, right? The first thing we need to do is find the rate of change. So we need to determine whether or not that is linear or exponential. So be careful, because a lot of times on your tests and exams, they will mess with the table, right? What you want to find is points that are directly next to each other on the table. So 1 and 2 is a great place to work, but if you can't use a 1 and 2, you could use a 3 and a 4, or a 5 and a 6, or whatever points you want, ideally ones that are close together. So you are going to first figure out those 2 points, right? 7 and 14, and you're going to first determine if it is arithmetic, right? If it is in a linear equation, it's going to be easier to solve. So we're going to pretend like they're all arithmetics first, because it'll make things easier for us. So between 1 and 2, we have a difference of 7. 21 plus 7 would be, or 14 plus 21, 14 plus 7, Mr. Cartwright. 14 plus 7 would be 21, so our third point would be 321, our fourth point would be 428, and our fifth point would be 535. So it works, so we know we are correct, right? One way is to find the rate of change is what I just did. The second way we're going to find the rate of change is using our slope formula. So to find slope, what we would do is we take our 2 y values, right? In this case, they are 7 and 14. And we could have used any numbers we wanted, but 7 minus 14 goes on top, and the direction doesn't matter, or sorry, which one you goes first doesn't matter as long as you stay in the same direction. So since I use this y value first, I'm going to have to use this x value first. So the 1 is my x value, and the 2 is my x value, and those goes on bottom of the fraction. But remember that I have to stay in the same order. So 1 minus 2. So my rate in this case, if I was using the table, would be times 7. This guy would be negative 7 over negative 1, which would be a positive 7. So either way you do it, you get the same rate of change of positive 7. Now, right, we have y equals 7x plus b. right? We figured out our slope, our m value, our rate of change. Way to go, Mr. Cartwright. Now we just need to figure out our b. Sometimes they give it to you and you know a 0 step. And if you know a 0 step, that's awesome. If the 0 step is given to you, you automatically know your a or your b value and you're like, done. Plug it in, good to go, right? If it doesn't give it to you, there's 2 ways, right? You can use the recursive method of going back 1 step. In this case, we would subtract 7 to get 0. So b in this case is 0. Or what you could do is plug in 2 numbers, right? Plug in one of your points from the table and prove it to be true. So if I plug in a 1 for my 7 value, for my x value, oh, no, it's not going to let me do that. 1 right there, 1 times 7 is 7, so I know that I am correct, right? So that is how you would do it from a table if it was a linear sequence. Okay, now I'm going to give you an exponential sequence, and in a quiz or a test, I won't have to tell you, but since this is learning, right? Cool. 0, 7, 1, 21. And 263. Okay, so I gave myself an easy pattern to work with, but what we should first do is see if it's arithmetic, right? So between 7 and 21, there's a difference of 14. So we add 14. 21 plus 14 does not equal 63. So if we have a different difference between the 2 numbers, right? Then we know we have a geometric, right? You can't have a line that doesn't have the same difference between 2 numbers, right? So if it's a line, it's always going to have the same difference. Since this one clearly doesn't, we know that we have a geometric, and it is a pirate, right? All exponential equations are pirates because they like to increase their bounty faster. Man, so many dumb pirate jokes. Cool. So how do we find out our values? First off, we need to find our R value, right? And to do that, we're going to take our second number and put it over our first number. So 21 goes on top, 7 goes on bottom, and we get 3. So y equals blank 3 to the xth power. Now there's 2 ways we could do this, right? Number 1, we know that our starting value is 7, right? It's given to us, it's the 0 point, we're good to go. We could plug in a 7 here and we'd be done. Sometimes it's not going to be given to us though. And what we can do then is we can plug in a point, right? So down here we have the equation y equals a times 3 raised to the xth power, right? And that's as far as we got with just the ratio. So what we can do is we can plug in this point, 263. 2 goes in for my x value. 63 goes in for my y value. And then we just have to make it true. So 2 squared is 9a equals 63. And if we divide 63 by 9, we get our a value. And a in this case equals 7. So we got 7 either way you looked at it, right? And so that's how you find it from a table. Finding it finally from points, I'm going to have to do this a little bit faster, so let's go. 1, 3, negative 2, 4, right? First thing we have to do is we have to find the rate of change. In this case, I would tell you whether it is arithmetic or geometric, or I give you multiple points. Let's start with an arithmetic. So how we would find slope is we subtract the values from each other, right? So if I have 1 and negative 2, my x values, right? Those go on bottom, 1 minus negative 2. And you could go the other direction. Let's do that, right? So instead of 1 minus negative 2, we have negative 2 plus 1. All right? And then what we have to make sure, since we went the other way, is we have to do 4 minus 3. We have to stay in the same direction, right? So 4 minus 3 goes on top. We get 1, and then negative 2 plus 1 is a negative 1. So we have a slope of negative 1. Cool. All right. This would be minus, actually. Sorry, that's what Mr. Cartman made a mistake. We subtract both on the top and on the bottom, so this is not negative 1, but negative 3. So we have a slope of negative 1/3. Now we can plug that into our equation. Y equals negative 1/3 x plus a, or plus b. The only difference is if we were doing a geometric, it would be negative 1/3 raised to the x power times the a value. So that's the only difference that we would have between arithmetic and geometric. And remember, I'd either tell you or I'd give you more points. Anyways, plug in our 1 and our 3. 1 goes right there for x. 3 goes right there. Negative 1/3 times 1 is negative 1/3. And that needs to get all the way up to 3. So b has to be 3 1/3. So our final equation then is y equals negative 1/3 x plus 3 1/3. Cool. Hopefully that all made sense to you guys. Please return to the live classroom.
Well, with this award, that I made up and gave to myself, I've realized that I really conquered the math book. I've beat legendary singers, battled global pandemics, beat superhumans in dunk contests. There's really nothing left for me except for to challenge the #1 selling musician of all time to an epic rap battle. That's right, Drake. I'm calling you out. You think you spit the hot fire? If you get too close to Mr. C, you're gonna get burned.
Way off in it.
Stay tuned this Friday for the epic continuation of Mr. Cartwright Saves Halloween, the epic rap battle of the century.